Carlo Pinto.
Hi, hello.
Hi. How are you doing today?
I'm fine, thank you. And you?
All right. So you're gonna present your paper,
Yes.
right?
Can I share my
Right.
screen?
It's great. Great.
Okay.
Yeah.
Thank you.
Very nice, and also it looks very fantastic on your background.
Oh, it's the Lelo.
Is it in your office with the?
No. It's the. Oh, I wish. No. It's the Lelo's Library here in Oporto, the city that I live in the north of Portugal. Yeah, it's a very nice. Yeah.
Yes, it looks fantastic.
Yeah, a very huge line to visit this library. Yeah.
Okay. Right. I think it's time to start.
Okay. Can you see my slides?
Yes, I can see your slide and presentation time. As I was informed, is around 20 minutes. I mean, yeah. Okay. So don't too much hurry. So so just relax and keep on around the 20 minutes for your presentation time.
Okay, thank you so much. So I'll put this in slide show.
Yeah, Lady Pinto, you have floor to present your paper. Thank you.
Thank you so much. First, I would like to thank the organizers for this opportunity to be here and present our work. So I'm going to talk about the expectations of a Gen Zer in the teaching of math courses in higher education. So I'm a higher education teacher, and so I'm using these agile or active learning methodologies to teach my students mathematics, which sometimes it's not easy. I teach at an engineering school, and though it's an engineering school, my students believe that mathematics is not important, and unfortunately, some of them at least believe that. So I need to motivate them and engage them, usually with real world problems, and to learn mathematics. So this is a joint work with my colleagues George Mendonça and Lourdes Babo. George Mendonça works with me in the School of Engineering, and Lourdes Babo, she works in the School of Accountability in Oporto, also in the Polytechnic of Porto. So I like very much this slide and what's written in it. Confucius, already in 450 before Christ, he said, I hear and I forget, I see and I remember, I do and I understand. And this is extremely important in our school because it's a school of engineering. They are very much keen to apply their behavior, their knowledge in practice. And so this is extremely important. Then Benjamin Franklin in 1750, he said, tell me and I forget, teach me and I remember, involve me, engage me, make me a part of the learning process and I will effectively learn. So, and then in 1938, John Dewey said, there's an intimate and necessary relation between the process of actual experience and education. So again, experiential learning is extremely important. Then you have the Cone of Learning from Edgar Dale in 1969, and you can see that I only remember 10% of what I read, but if I repeat what in a discussion, giving a talk of what I learned, of what I was told, then I remember 70% of that if I speak about it. And if I, instead of only speak about it, I do things, I remember 90%. So this is extremely important. I believe in all levels of education, since kindergarten to higher education and beyond. So who is a Gen Zer? So they are our class of 2019. They are a generation 1 million, larger than the previous one, the millennials. They were known as the millennials, and they will enter the workforce in huge numbers. So they were born around 1996, and 54 of them believe that their job will come through digital and social connections. So this is extremely important, because since we were born until now, there was a huge digital development, and these students were born in this new technological age, and they like to use it, and they feel confident in use it, and they use the technology since the way they were born, almost. So they are a generation which is more global. They are more or less all over the place in the internet. They are in Twitter. They were in Facebook, but not now. They say so for parents, so for the elders. But they are in Twitter. They are in a lot of other, in Instagram, etc., etc. So they keep up with news, with some influencers, unfortunately for one side, because most of them are only worried about fashion, and not most, but there are a lot. These Gen Zers are more demanding than we were. They like their 5 minutes of fame, and they are looking also, which is, I believe it is extremely important. They are pro-social. So they believe in those sustainable goals. They worried about healthcare, higher education, mental health, economic security, which is nowadays a very huge problem for everybody worldwide. Why? Because before we were living the COVID-19 pandemic, right? And it's not over. Let's say we are still living an epidemic, but now we are in a war, and I just hope it doesn't turn out to be the third world war. Let's hope not. And so it's extremely painful for them, because they are used to live a good life, and they haven't been in any war. They haven't suffered any, let's say, they haven't had very troubled lives. So it strikes them quite more than it does to us. They try to be an active part of political and civic engagement. They believe in race equity, and they believe in the environment. So the sustainable development goals are extremely important for them. So they want to learn real-life practical skills, and they place a lot of importance on hands-on experiences, like internships, and they like to be paid. Although most of the companies don't like to pay them, they like to be paid for their internship, for their work in these companies. So this places a high demand on us as teachers in kindergarten, in the primary education, secondary education, higher education. Why? Because we were once upon a time taught in a completely different and traditional way. But we have to, it's not we can, we have to apply different approaches. Otherwise we will lose these teenagers who have a lot to share with us, to contribute to society, and they want to contribute to society. So 79% of the Gen Zers would like to integrate a higher education experience with employers' internships. This is a lot. We didn't think of it once upon a time when we were young. So we have to move from classes, traditional ones, big theaters, etc., to something more like small groups working in labs, etc. So we need to apply different active learning strategies, agile methodologies in our classes. It cannot be we cannot use apply the same strategy technique in all of our classes, because the students are different. That's also another another challenge for us, because we have different students in different classes, and also inside each class we have different students, and so we need to be able to understand them and provide them with the best knowledge that they deserve, that we can do. So asking students to say, to write, and to do, it's extremely important. So our classroom must be flexible. And how can we do this? Well, we have a variety of agile and flexible methodologies to teach. We have Jigsaw, which is to split the classes in the students in groups, 4 students, for example, per each group, and then give them a subject to study. And we have these expert groups and the other groups, and then the students themselves learn with the people from the expert groups, and they join in the end of the class. We can have think per share, which is once in a while in class you pose one question and ask 2 students at a time to reply to that question and explain why. You can also use problem-based learning, challenge-based learning. You can use 1-minute papers. So it's a myriad of different and interesting ways of teaching that you can use to engage, to promote, and to develop motivation in students. I know you can say, well, the syllabus is extremely heavy, and we have the time goes by very fast in our classes. I know that, everyone knows that, and we struggle. Each one of us, when we are teaching, we struggle with time and with the heavy program. It's really heavy. Some programs are really heavy, but the students must also learn, right? We now have, it's also another big challenge for us teachers, because we have to teach them the essential skills. They're called now essential skills of this industry 4.0 or 5.0, whatever you want to call it. What are these essential skills? They are the hard skills, that is the techniques, the theory that you can apply, and the soft skills, which is collaboration, motivation, negotiation, so empathy, etc., that they need to have, because they want to go to the companies when they leave higher education or during their internships, and the companies themselves are eager to have these students with all of these skills together. Once upon a time, the companies couldn't care less about the soft skills. But nowadays, they really do. They like people that can work in teams, that can promote the development of the company, because the companies are built by people, with people, and they have a lot of people working there, and they need to work as a team for the whole purpose of the development of the company. And so there's a big emphasis in these soft skills. On the other hand, if the students don't have the hard skills, then they can only be maybe they can only work maybe in the office as public relations. So that's a company needs more than that. They need people to the shop floor until the CEO. So there's a lot of roles that the students, the employees must fill in. So we need this. We need to have a strong cooperation between synergies between the higher education and companies in order to provide our students with the skills that they need for the work environment. In terms of mathematics, we have different learning styles. Let's say I have already mentioned this. We have different students' personal goals, and we need to contextualize mathematics inside the course that we're teaching. If I am teaching a Bachelor of Engineering, let's say of Civil Engineering, I must, well, at least from my point of view, I should give to my students real-life examples of civil topics. If I am in, for example, in an electrical engineering bachelor teaching, let's say, linear algebra, calculus, statistics, I should give examples to these future electronical engineers about electronics. So application of mathematics in electronics. So this is the best way to be able to create empathy, trust, and give empowerment to students in the subject that they are learning, and it's a way of step by step telling them that mathematics is extremely important in their engineering course. Why? I also tell them this: if you don't know mathematics, if you don't know the basics, which is the base of your course, then if you are a civil engineering, probably the bridge that you design will fall. If you are a mechanical engineering or automobile mechanical engineering, probably the car that you designed or the motor that you have designed will fail, and etc. Because everything, you have mathematics in everything. So we need to ask students to think critically, to reason mathematically, to pose and solve questions, to handle mathematical symbols. It's extremely important for them, these C6, because usually they are very much afraid of the symbols and the Greek letters that we quite often use in mathematics to write some theorems and etc. And we need to teach them how to communicate in, with, and about mathematics. So teaching mathematics in engineering involves all of this: critical thinking. So there's a big mathematics circle around everything. It has to do with the interdisciplinary and systems thinking, innovation and entrepreneurial behavior, rigorous engineering. We cannot do good things without being rigorous. And as an intersection of all of this, we need to be an ethical human being. So for the engineering toolbox, there's a lot of mathematics going on and a lot of different courses. that most of the courses in engineering must know at least the basics. And this gentleman, Nice, in 2003, said that an engineering student must possess the ability to understand, evaluate, do, and use mathematics in a variety of intra and extra mathematical contexts and in situations in which it performs or can play a role. So this is extremely important. Everyone is looking at everyone. So there are a lot of people who think of the applications of mathematics and the importance of it in engineering courses and etc. So we must find the right balance between the theory and mathematics and the applications. This has to do, this right balance has to do with the course that you're teaching, the bachelor course that you're teaching, with the students that you're teaching, etc. So just like once upon a time when you started to teach or when you were in higher education, your teachers, professors had those classes planned since forever. Nowadays, you have to have planned classes, but you have to be able to adjust your class and your plans as time goes by. It's not easy. It's not easy to be a teacher. It's quite challenging. It's quite motivating for us too. But it's time consuming to be a teacher nowadays. Again, this has to do with mathematics. We have to put this related to their life problems and then develop in students critical analysis of methods and solutions. Because I don't know if you realize this, but if that even happened to you, maybe yes, maybe no, I don't know. But once upon a time, I was teaching numerical methods to some students in a bachelor in engineering, maybe 15 years ago or so. And they had bought some calculators, extremely expensive, etc. I don't know why I always tell them that you don't need those expensive calculators, at least not in my subject, because you can do it in the regular ones with 4 operations and exponentials, logarithms, and it's all. You don't need very expensive calculators. But okay, this student had bought this very expensive calculator, and he forgot something important. And I'll let you know in 1 second what it was. And then we were doing some calculations, and the result was a half, 1/2. And so, yeah, and I wrote in the blackboard or in the whiteboard 0.5, so in the decimal places. And he told me, but teacher, my calculator gives 0. And I thought, come on, please. If you have 1 orange and you cut in half, what you get? 0 oranges, 0 halves. So, but my calculator, teacher, it gives 0. Why? And I told him, just check how many decimal places you are allowing your calculator to display on the screen. And then he went there, and then he saw that he didn't allow any decimal places. So this is why the result was 0. It was truncated. It was not rounded. And so the critical thinking, the not expecting that the output that comes from a machine, whether it is a big fancy computer, the last generation computer, or if it is a calculator, we need to look at the result and figure out for ourselves if that result, even if it's not even if you don't know the right answer, even if you don't know if it's 0.55 or 0.57 or 0.8, we need to know that the result must be something between 0.5 and 1, for example. We must be critical. We must do this analysis, the critical analysis, before looking at the result that some machine gave to us, and we just have to accept it. We don't. We need to be critical, so critical thinking is extremely important in our students. Nothing is a black box. I even told them, when you click on sign of something, sine or cosine or tangent or whatever, one of these trigonometric functions, when you click it in your computer or in your calculator, the machine doesn't know how to read sine or tangent. It doesn't understand what that means. It has a routine behind that has a numerical series that approximates the true value of the tangent, etc., in that value of x. And sometimes the students don't realize this, and there's something that we need to tell them. So I've already mentioned the soft skills: conflict management, responsibility, teamwork, critical thinking, also self-motivation. Leadership is extremely important. This week I was in a workshop. Actually, I was part of the organization, and we have a very good panel of CEOs of companies from Bosch, Grow, etc. in Portugal, of those companies in Portugal. And they said that the soft skills are extremely important, and they like the students to be interventive, to be leaders. So, but also to learn there inside the company. And so there were also issues related to, how do you say, working from home. And for people that are just starting a company, they lose the best feeling, the environment of the company, these relations, this development of these relations inside the company with the other colleagues, for example. So we have once upon a time also, no, it was from 2017 till 2020, a project, an Erasmus Plus project, which was called Drive Map, in which we applied a lot of active learning techniques to teach math to our students. There are nice videos in this website. I don't know if you'll see it because I just share this presentation, but if you want, then I can send it to you or put it in the chat. And now we are just starting in February 2022 in another project, Math Digger, and we are developing digital escape rooms for higher education to teach math. We will start with the calculus course. So this is something very interesting. We are very keen to work in this, and we hope to have in 3 years very good outputs to show to you. We are working with the Maxware company. They work in virtual worlds to enhance and optimize our reality. And in our project, what we want is to motivate, engage our students in learning, in this case, calculus, by moving inside the escape room and solving problems in a fun way. Fun, but also they have to learn while they're doing it. So we will have gamification, of course, and also some of the problems will have GeoGebra also. So our outcomes will be to have this finished math figure user interface. So students can go there, log in, and use the escape rooms to learn calculus in this case. And also we will have a set of tutorial videos of math figure, both for students and for teachers. It will be so an open platform. So we have some partners, you know them. We are from the Polytechnic of Porto, the School of Engineering. We have another partner from Portugal, which is from Polytechnic of Coimbra. But then I'm sure you know Johannes Kepler's University and Jolt Lavixa, he's working with us. We are also working with a Greek university, the Hellenic Mediterranean University, and also with the Saleh from the Hacettepe University in Turkey. So this has been a fantastic adventure. There are multiple questions. We need to define new curricula, develop new pedagogical materials, new peer learning methods, the assessment, types of assessment, how to do it, include the ICT, e-learning, B-learning, and dissemination and exploitation of what we have been doing and other people have been doing, for instance, in this type of conferences, etc. And I always remember Rod Stewart. I know it's it's quite old, but we shall prevail. So at least we are motivated enough. We are motivated enough to continue with this quest. We don't know if we'll ever reach a goal, let's say, our goal, but we'll keep pushing forward and moving forward in order to be able to challenge ourselves and our students. So thank you so much, Christoph, for what you wrote in the chat. And don't forget, success consists of going from failure to failure without loss of enthusiasm. That's how you won the Second World War. And also very important, when the student is ready, the teacher appears. But when the student is truly ready, the teacher disappears. It's a mentor, it's someone to talk to, but it's no longer called a teacher. So thank you very much for everything. I hope you enjoyed my talk, and I'm available for questions that you might have.
Okay, yeah, thank you very much, Carlo. And yes, thank you very much, which is, yeah, interesting to find out mathematical path to face with yeah, many prejudice or many sympathetics in a variety of field and ideas. Okay, and we have now final presenter to deliver his ideas. Well, including me, Mr. Sin-dae-yong. He's a PhD student of Department of Geography Education, and also he's working for the Center for Creative Research contents with the artificial intelligence and data analysis at the university in our institution. Right, okay, Mr. Sin-dae-yong, are you ready to present your presentation?
Okay, can I share my slide?
Floor. Thank you. You have 15 to 20 minutes.
Okay.
Thank you. You have floor.
Okay, I will share my slide here. Then.
Yeah, I can see that.
Okay. Okay, good evening from South Korea. Hello, everyone. I'm Dae-yong Shin, who is a graduate school student in the Department of Geography Education. Man, actually, you are heard about this one before. Yeah. Today, I would like to talk about the topic of DNA-based EPBL model development and application to elementary school convergence classes. Yeah, actually, it's so long, but yeah. Okay, let's go in. Today's contents comprise the 5 parts like introduction and DNA-based EPBL and implementation, result, and conclusion. That's all. So we will talk about those 5 things from now on. Okay. So first one is about the first introduction. As we know, with the progress of the fourth industrial evolution and revolution, the development of IoT and big data and AI has been developed. So it has affected not only amount of knowledge but also educational needs for new knowledge and technologies too. So therefore, the students of the future society will need to learn about those kind of many abilities, such as like using and combining existing knowledge and skills and critical thinking and problem solving and creative thinking. So in addition, the online classroom environment, which dramatically developed in the post-COVID-19 era, soon leads to the demand of blended learning. So actually, in my opinion, now is a kind of blended learning era, but now it's disappearing now. Seems a bit disappearing now. Yes, and also there are many kind of researches talking about the 6C, which is including the communication, collaboration, content, critical thinking, creative innovation, and confidence. So it will become the education's core competence in the 21st century, and actually it's really well-known stories. And the 21-22 curriculum in South Korea has mentioned the future learning and evaluation method in the digital era that are linked to the actual real life and world, to nurture talents with the capabilities of future society. So therefore, learning method focused on student participation and process-based evaluation. Yeah, that's kind of those 2 things now became important again and again in South Korea too. So in this context, the Center for Creative Education, which I'm working now, is intends to propose one education model for nurturing those kind of future creative talents of students in this study. So the purpose of this study to confirm is as follows, like these 2 objectives. First is to develop a DNA-based EPBL model and some interdisciplinary convergence class programs, which is based on this EPBL model. And the second one is to apply the DNA-based EPBL class programs to the actual field. Actual field means actual school classroom means to check the accessibility and usability and the effectiveness of those programs. I mean, to checking those kind of effect. So for those research goals, this study firstly intends to create a class model. I mean, we call it DNA-based EPBL model. Then we will remake those kind of class program based on DNA EPBL model, because this kind of DNA-based EPBL is just a model. It's just a model. So we need to think about more kind of in detail situations, such as like students' ability and some kind of class environment, which kind of devices can be available or not, or those kind of things too. So, and then we will implement those made class programs to the actual the classroom, then we will analyze the result of satisfaction survey or something. So the next is the part of the second one, DNA-based EPBL. Yeah, this is a kind of core part in here. So actually DNA, which is covered in this study, means the data, networks, and artificial intelligence. And the data literacy is defined, actually is well defined in so kind of many literatures and studies. But in here, we are defined it as the ability to collect critically and process and analyze the data for problem solving and to use the result and statistically to communicate with others or construct their own knowledge. That is the definition of this data literacy is here. So yeah, and then next one is APBL. Actually, we are talking about the DNA before. So actually this APBL is generally means a method that connects online web platform-based learning and problem-based learning. Yeah, actually they are two kind of based learnings are here. So it refers to a method that allows learners to use some kind of main procedures of problem-based learning on online or on a web platform. That is the EPBL in here. But if the EPBL applies the actual school field, mainly use the three methods like using ebook or using online meeting app or using SNS platform. The first one, using ebook, is really flexible and easy for self-studying of each student, but it is really hard to continuously procedure of ebooks because making this ebook is kind of time consuming, so it's really difficult to do that. And also the second one is using online meeting app. It's kind of really good way because they can do some kind of real time two-way communications is possible in here. But the advantage of self-learning is not to be significantly sacrificed. I mean, how can I say, the teachers and other students, they only can check when this kind of app is running. And the third one is kind of really good one. Actually, this is located in the middle of these two methods, but there's a kind of huge problem, like kind of possibility that privacy problem may occur in this case, because this is an SNS which is having my account. Okay, then we made the DNA-based EPBL model like this. It's a kind of structure of this model. So actually it has 4 parts. One is environment, and other subject, contents, and program. So each part is linked to the next one. And then the teacher considers the student's level, ability, and class environment, and the topic of today's class or something like that. After that, the final step is plan. I mean, the making a kind of DNA-based EPBL class course. Class course means a kind of lesson plan and apply it to the classes to teachers. So this is the EPBL model. So in here, we will talk about the contents and problem parts problem parts that I mentioned before. Actually, they should be adjusted according to the other remained parts, I mean, environment and subject. Actually, according to the Kilbig and Shurkis 2019, they have mentioned about the data that can be used in data-driven educational activities by classifying them according to 5 items like scope, selection, curation, size, and messiness. And also contents also said about something like that, but therefore referring to the contents of the related research, the item of contents in here will be divided into the 3 steps, like 3 things like can be things like the beginner, intermediate, and advanced level in here. So, and then they can be used as a kind of guidance or reference for the class program production. I mean, when they making or planning about their class program, they can refer this. They can refer this table. And in addition, since the class time to be allocated in the different depending on the class topic and subject of teachers and the level of DNA element or DNA tools. So following class divisions are suggested by referring to the class type of PBL class model. And also in the corresponding class type development, referring to according to Chui, and the composition of KNUE, CEC. CEC means the Center for Creative Education that I'm working now. So in here, they made those kind of, how can I say, those kind of this classification like ABC, EPBL class type or something like that, and then referring those kind of class type development, we remade it like this. So total 3 stages were divided into the classification in here. So you can check the reduced and normal and advanced. Actually, this is a when you just pick the first letter, then is like RNA. Yeah, it's a kind of the friend of DNA. It's like that. And then moreover, examples of the contents of the DNA-based EPBL class model and teaching and learning stages were presented to teachers so that the teachers and learning stages of DNA EPBL class model according to PBL configuration could be configured as follows like this. So you can check what is the contents of each lesson progress and each steps of there. So after that, after giving those kind of all things, then teachers will provide their own DNA-based EPBL class program. So after that, we need to but actually as a part of this okay, then okay, now is the time to talk about implementation. I'm sorry. So as a part of this center's research production, there's one teacher training courses was opened the last year. And also total 55 teachers were participated and completed the course. In the process, total 4 teachers conducted interdisciplinary convergence classes at the time. So they made some kind of customized class program was created, and then they are applied by referring the class model according to the school they are working. I mean, they are just considering about student level and those kind of things and so on. And regions are actually the regions are Seoul, Gyeonggi, Chungbuk, Gyeongnam. The 4 regions and participating schools all of them are elementary schools in each region. So the total 126 students from 4 schools were planned to apply at the time, but actually is over. Implementation result was verified using the class satisfaction survey and provided by the Korea Foundation for Science Creativity and the creative problem solving ability test questionnaire suggested by Joe. So we can see this
Mr.
one.
Shin, you have 5 minutes left.
Okay.
Yeah, less than 5 minutes to finish.
Okay, I will try to talk about more faster than. Okay, this is a result part. The analysis result are followed like this. So more than previous plan, 166 students participated and answered, and the overall satisfaction average was 4.0, which is relatively high. However, the number of respondents from the specific school accounted for nearly half of the total. I mean, the Dusan Elementary School in Seoul. So that, yeah, the satisfaction and also the satisfaction level also different significantly. And after examining the result of in detail satisfaction survey of our four classes, we found that when the score of the class difficulty, I mean the question of the score difficulty, class difficulty was somewhat easy. This easy means more than 3 points, more than 3 points. So it means that overall satisfaction, interest in class participation, application to real life, and those kind of more kind of the indexes are increased. As a result of the analyzing student opinions and opinions about also evidence, one of the evidence of this one. So therefore, it can be understood that there are some kind of score the corresponding class program was low, that reason. But actually, actually there is something, but I'm really sorry I cannot see you here. I cannot show you here. The analysis of class effectiveness using the creative problem solving ability test like this. Actually, this is not the measure. This is not so. How can I say? We cannot see any kind of significant things and all. But actually, there are some point of significance, like you can post interest or post creativity, or those kind of indexes are increasing significantly. So this is a result of the result. This is a kind of small overall conclusion is here, but actually there is no time to talk about this one, and I will skip it and going to the conclusion because there are some parties are overlapped. So here is a conclusion of this research. The goal of future education in the fourth industrial evolution era is to nurture creative convergence talents with many abilities such as like data literacy and so on. Therefore, in this study, the DNA-based EPBL class model was developed to contribute to the nurturing of future talents of students, and a field-type class program was produced. And the class was pilot of line, so by those teachers too. There was an overall positive response to the pilot application result, and some significant results were obtained. But actually, since most indicators have not seen any kind of significant level, so that's why we guess there are some kind of uncontrollable variables. And also that's why it failed to analyze the effect of this model. So maybe in the future research, we intend to analyze the effectiveness more clearly through in-depth interviews or preliminary surveys of each student who are participating in this. And also, in addition, by improving or disseminating the current teaching model and program, we intend to contribute to the cultivation of DNA literacy of each student and teachers more than now. So yeah, that is our plan. So okay, maybe it's the time to the end. So thank you for watching my presentation. This will be end. Thank you.
Right, thank you very much. The final presenter, Mr. Shin Dae-young, PhD candidate in our university under my supervision, and he talked about the data network and the artificial intelligence approach on educational purposes. Okay, so in this session we had 5 papers presented by the a number of participants, including presenter, from the materialism discussions and the digital competence in STEAM education and color music topics. And also we talk about the millennium, well, I don't know, how can I say that, generation gent from the mathematical courses in higher education level. And finally, we had been involved in DNA discrete data network and artificial intelligence-based EPL model development at the elementary, I mean primary school levels. Okay, and now we will have around 50, oh, I'm sorry, it's exactly 12 minutes discussion time for all of the presenters' papers. Right, okay. Any questions? You can turn on your mic and then share your ideas with the presenters. Okay, who gonna first? Do you have any questions on the floor? And you can also leave your question on chatting box in your Zoom screen. So any questions? So can I, Carla Pinto, are you still here? Pinto, Carla Pinto, are you still here? No, he's a little bit left. Okay. Any questions from the floor? I will be very pleased to get your discussion topics. Right. So I think well, you can leave. I mean, until starting next session. For final closing by Professor Baek Sung Hee, you can also leave your question on the chatting box. So and we will pass your question to each presenter. And also, parallelly, another session is still running. So I think well, we need to wait. We need to wait until closing remarks around 10 to 8 in Korean Standard Time and 12:50 on Central European Time, 12:50. So I was told that the final closing will start at 10 to 8 p.m. on Korean Standard Time or 12:50 p.m. on the Central European Standard Time. Right, Pinto, are you here? Are you there?
Yes.
I can see that. I have a question about your presentation. I mean, so I'm geographer, but I have been working some sort of mathematical modeling application to geographical research and practice. So you mentioned about several dimensions of mathematical thinking or sometimes numerical thinking. So my question is about how much relevant critical thinking and mathematical thinking for the educational or research purposes at higher education level. I mean, when we talk about the mathematical thinking, sometimes we have to think about the critical thinking approach with some mathematical modeling. So is there any good example from your experience to apply critical thinking of mathematical ideas into, for example, computer science, humanities, or even social science, such as geography? So what is your suggestion or your experiences or whatever?
Well, there are several examples, real world examples for which if people don't apply simultaneous critical thinking and mathematical thinking, things can go wrong. For example, when we started here in Europe space research, they developed the Ariane rocket to go to the moon. And in, I don't know, the 90s, and then the first trip that this rocket, Ariane 5, did, it crashed. Why? Yeah, why? Because the model was right, mathematical model was completely right, but there wasn't the correct technology. So the computers that were used didn't have enough decimal places, so enough space to accommodate the decimal places needed for a better approximation of the solution of the mathematical model. And then the errors started to increase, and after some time it exploded. So after some time it deviated from the correct trajectory. And so from here, from the Earth, let's say, they switched the button and made it explode because they didn't know where it would go, because it was out of the trajectory previously defined. And so this is I believe an example of what an application, valid application, completely correct application of a mathematical model. Okay, it was really everything was okay, the equations, etc. But then they lacked something critical, in the sense a critical reasoning, thinking, because they forgot that they had to use approximations of the exact solution in order to design the trajectory. And so the Ariane 5, the computers had to compute at each step that solution, and then it deviates completely from the trajectory because we had numerical errors accumulating.
And another my short question is, when you mentioned the mass figure, can you see my
no, it's not that mass figure. I know.
No,
that's
right.
not that one, no. Because that one is for kindergarten and primary school.
Yes. So my next question is, do you have any plan to develop mass figure you presented for primary and secondary school?
No, it's level? Already there.
It's already there.
No. Plan to develop maybe in future projects for other areas in mathematics, other courses, algebra, statistics, etc. Yes. And also other subjects, chemistry, physics, informatics. So as long as you have the base set up, the base for the escape room, the basic platform, then you can do other things.
Yeah, my suggestion is to apply your idea into social science topic, for example, geographical analysis. And now the geography has been increased to their application scope to data analysis, which is sort of required mathematical thinking way or mathematical skills to analyze the geographical data analysis, something like that. Yeah. So maybe your idea quite useful for geographical idea extension. Yeah, that is my question. Yeah, thank you for your presentation. Yeah, thank you.
Thank you for your questions. Very relevant. Thank you so much.
Yeah, and from the audience on the floor, any audience can ask you question to the presenters. Does anybody want to ask questions for all of the presenters in this session? Right. Okay. I just told from the local committee members. Another session, session 2, is also completed right now. So it is time to start closing remarks session by Professor Baek Sung-hye of our university. So, Professor Baek, are you here? Are you around? Or you're still in another session, session 2? Right. Or anybody from the local committee member response? How can I? Right, okay, I will let you know. So I will let you know when we're ready to have final closing remarks. Until then, can you have 2 or 3 minutes break, and then we're gonna start again. What about this idea? Just bring your tea or coffee. Okay. See you. Yes, see you 2 minutes later or 2 or 3 minutes later. I will re-announce. Okay. Thank you very much.
Bye-bye.
And see you soon. See you in a minute. Thank you. Bye.